So hello friend. So today I will discuss new topics, that is metal oh sorry analytical chemistry, and, and this topic is also very important in CSIR point of view. So in last my lectures I have completed 4 videos of organometallic based. So in this lecture I will discuss analytical chemistry. So I will give some basic introductions of analytical chemistry. Some selective topic I will discuss. Okay, so if you are not subscribed my channel, please subscribe to my channels, so that and click the bell icon, so you will get the easily notification time to time when I upload the video. Okay, now we'll start. So what is analytical chemistry? So we'll discuss analytical chemistry. Analytical chemistry. What is analytical chemistry? So it is basically the chemical characterizations of matters like contains particles, several particles in the samples. So in both manner, qualitative as well as quantitative. So it is basically the chemical characterizations of matter, and it is basically in both way, like qualitative as well as quantitative. What is qualitative and quantitative? Qualitative means some amounts or some quality, how much qualities sample is characterized, and quantitative means how much amounts. Let's say you have took 5 gram sample, and if you are only the characterize 2 gram, so these are the quantitative. So and what is the importance of this analytical chemistry? Because if I read something, then people should know what is the importance, why we are reading these things, or study these things, or something learning these things, why or what is the importance of your daily lives. So it is very useful our daily life, because chemical makes of everything we use. Okay, and one scientist uh, said, scientist name, he already passed away, so his name is Charles and Raleigh, said the analytical chemistry is what analytical chemists do. So he said analytical chemistry is analytic what analytical chemists do. It means that chemists or scientists, those things they are analytic and are analyze, that is known as analytical chemistry. Okay, so now I move analysis. As I told, analysis basically we analyze in two way, like first qualitative, second way quantitative. Okay, okay. So what is qualitative? It is basically the identification of elements, ion, ion, identification of elements, ions are compound. Which is present in sample. So this is the qualitative, and quantitative is something determine the how much of one or more constituent are present, means how much one or more constituents are present. So this is the quantitative. So some notes points. Analytical sample note. Analytical m- maybe solid, liquid, or sorry, gas, or mixture. Okay, so if we say in whole analytical chemistry, we basically study the separation, identification of elements, compounds, ions through qualitative and quantitative determination composition of different substance. Okay, so in this technique, now we what we inside this analytical chemistry, which topics are important in exam point of view, CSI and NET GATE, and other competitive exams like BSc also entrance exam. So further these techniques characterize like analytical technique characterized into two ways. First, instrumental. Second one is conventional. Into two way. In instrumental, we have to study too much, and instrumental is very important. So basically I will discuss inside instrumental something separation, thermo analytical, and spectroscopy, and these things we will discuss in instrumentals. And inside this I will discuss chromatography, and second was is solvent extraction, and inside this discuss number 1 DTA, DGA, DTA, and DSC. And through spectroscopy we will discuss atomic absorption spectroscopy and atomic emission spectroscopy. Through conventional, I will not discuss this thing, but I will give you some classification, means through volumetric and gravimetric. So basically thermoanalytical and spectroscopy is a very important of exam point of view. So and this one also is important, but basically These two things are very important. So now I will discuss the separation. So what is separation? First one, discuss the separation. In instrumental, discuss separation. So what is separation? So it is a technique which is used for separate two or more component which is present in solution. It is a technique which is used for separate two or more component. Two or more components. So which is present in solution, which is present in solution. So what is important of separation? So importance is through this identify the components in a mixture. Identify the component in a mixture. Okay. Number one, number A, number B. Through this, drugs can identify in a blood samples. Drugs can be identified. It is basically theoretical things. So we have to write in theory manner. This topic is mathematical. It is basically theoretical manner, theoretical things, totally theoretical based. So identify drugs can be found in a blood sample by chromatography. So these are the important two main important things, mainly basically. Now separation is basically two types I have mentioned here: chromatography and solvent extraction. These two way we can separate any components. Okay. So I will took one by one. Okay. Okay. So first is chromatography. Inside this, there are several types. There are several types of which can uh, separate the samples. Set this number A on the basis of mechanism of separation or principle. Like first adsorption chromatic assay, adsorption chromatography, HPLC. Second one is partition chromatography, like paper chromatography. Third is ion exchange chromatography, exchange chromatography. So, okay. And the last one is a size exclusion or gel permeation chromatography. So these are the way how to separate the components. And second, be on the basis of mobile phase. So what it is mobile phase? It is a phase, something which is moving any. It is basically a moving phase. Okay, as you know, then mobile phase is basically mobile. So through moving mobile phase, again we differentiate solid. As I told, mobile phase is something moving phase, like in liquid. In this phase, you don't use any solid sample. So, in this way, only we use liquid, gas, and supercritical fluid. Okay, so liquid phase is basically the normal phase chromatography, and reverse phase chromatography, hydrophobic chromatography. Through gas, only the gas chromatography. So liquid is again differentiate in three way: normal phase chromatography, reverse phase, and third is hydrophobic phase. Okay, so now we will discuss third, RC on the basis of shape of chromatograph chromatography. Wait. Inside this, we discuss one planar and second column. This two way is very important for separation. We are using in our laboratory in MSc levels or PhD levels. So through this paper planar, use the TLC, and second paper chromatography. Through this column chromatography. We again characterize into a packed first one is ion exchange and second one is HPLC, and in this tubular first gas only chromatography. So now we will discuss first in through planar we will discuss thin layer, because this is we are used in our daily routine, like in laboratory TLC. So first we will discuss first, second TLC. So what is full form TLC? Thin layer chromatography. Thin layer chromatography. So some points. Point first, TLC separates components of mixture on the basis of polarity. Separate components of mixture on the basis of polarity. Second point, like two phase. First is stationary phase. Second is this phase is basically use silica gel which is polar, and B is mobile phase. Solvent solution. Like liquid, gas, or gas. Okay. So now we will discuss the experimental clarification. So what is experimental clarification? So experimental experimental TLC. uh, First we took the TLC plate, which is made of glass. This is like TLC, and this thickness of this TLC is 0.2 mm, and here spot the our sample, which is distance of around 1 centimeter. Now this TLC plate dip into the solvent solution, which is little bit above this solution. Like, don't dip your spot level of these plates. Okay, so like this you dip like this, don't dip fully. Like this you have hair spot. So if dip this plate, then what will happen? Some spot will go up, like this, like this, like this. So some spot will go up, and your hair, you should mark here your solvents rise, and here is your sample, spot sample rise points. So this is happened through the via capillary actions. So, and here is this is indicate your how much your solution or is rises up to here. Okay, the solutions and this ones indicates, because this is less polar, indicate less polar. This indicates high polar. Why? Because this is high polar, that's why its movements is not that much in comparison to this, because it form it is highly polar, that's why its moments is not high comparison to this, it is less polar. So it form ionic bonding. So if okay, so it is important if we see in determine the retardation factor, RF, retardation factor. Through this we calculate the retardation factor. Okay, so what is retardation factor? How to calculate? It is basically the relative absorption of each component of mixture, and retardation factor is written like this: distance traveled by component A, like this, if you say this names A, if you dries this, then after that you should take outside this plate, and then you do all this mathematical calculation, measure all those things, spots, after keeping outside. Okay, after keeping outside, like this is A, this is B, this is your original spot, this one. Okay, so distance traveled by compound A, like this, and distance traveled by solution, travel by solution. This solution, this distance travel by this solution to up to here, so you should mark by pencils here, so you measure this distance. Okay, from here to here, and your spot A distance measure from here to here. Okay, so this is distance travel by solution, which is you have marked through pencil, and this RF value is basically in the range of 0 to less than 1. So its value will come less than 1. So now we will discuss column chromatography B. This is, what is this? This is okay, this is first planar TLC, and second was column chromatography. Okay, discuss column chromatography. Second, discuss the column chromatography. Okay, so what is column chromatography? So it is basically through this technique we isolate a single component from a mixture with use of column. Isolate single components from mixture with the use of this technique. Okay, so column chromatography, there are two phases which is taking place. First, stationary fixed phase, like use solid sample. Second, mobile phase, use the liquid or gas, something like that. Okay, so you should follow the steps. Step first, selection of stationary phase. example alumina, silica. Okay, and second step, column packing. Okay, third step, selection of mobile phones. Mobile face. So note points is through this stationary and mobile fields should be opposite nature. Stationary and mobile should be in opposite phase, because then after if these two phases are opposite, then you can easily isolate the components. Okay, so if we see these things via diagrams, so if we see like this column chromatography, this is stopper, this is stopper, and here if first fill the cotton plug, and here fill the sand bulb, which is totally inert and not reactive with any samples, and here we have to fill stationary fields. Yes, like silica. Okay, and here is your loaded sample. This is your loaded sample. Okay, and here this cotton plug you should take in less amount. Okay, so here you have took silica is polar, and mobile page is less polar, so these two things are just opposite to each other. Mobile is less polar, one is polar, the other is less polar, and like acetic acid or carbon tetrachlorides, these are the less polar species. So these are the all about things, and okay, thank you. If you have any doubt, then you comment me on below section and I will reply you. Thank you. Okay, bye bye.